In this lesson, we're going to be talking about algebra properties and geometry properties. And the reason we are going through these, because some of them are things you are very familiar with from Algebra 1, the reason we're doing this is because knowing these properties helps set us up for the very first type of proofs in geometry. We're working our way up to more difficult proofs that we'll do later, but the first step, or the idea behind proofs, is to get used to justifying the steps that you take. So what we're going to do is we're going to take simple things you already know how to do, like simplifying or solving equations, and we're going to justify each step that we take to solve those. So let's talk about some of these algebra properties that you should already be familiar with. The first four are operation properties, and they all refer to solving equations and keeping the equations balanced. You should know by now that whatever you do to one side of an equation, you have to do to the other to keep it balanced. So the addition property is actually called the addition property of equality. Just simply says that if A equals B, if I have an equation, one side is equal to the other, then adding the same thing to both sides of the equation keeps the equation balanced. So if I had something like this, and I wanted to solve that, and I had to add the same thing to both sides to solve it, then I would arrive at x equals 10 from this by using the addition property of equality. Okay? All right, let's do the subtraction property. Same idea. If I subtract the same thing from both sides, it keeps the equation balanced. So if I had something like this, and I wanted to solve that equation, I would subtract 3, the same thing, from both sides. Whoops. And that would give me x equals 7. How did I get from here to here? If it doesn't show me the step, you can just look and see what happened. What happened? The 3 moved. How did the 3 move? Well, I subtracted it from both sides. So that is the subtraction property of equality. That is the justification for moving from this step to this step. Okay, another one, the multiplication property, same idea, multiplying the same thing to both sides of an equation keeps the equation balanced. So if I had something like 1/2 x equals 9, how would I get rid of the fraction that's with the 2 or with the x? I would multiply both sides of the equation by 2, or in this case 2 over 1. And that would make these cancel. And I would arrive at x equals 18. Now I would have gotten there, okay? Arrived at that idea. How did I get from here to here? Well, to cancel this, I had to multiply both sides by 2. So that's the multiplication property of equality. Okay, and then the division property, same idea. If I divide the same thing from both sides of an equation, the equation stays balanced. And we'll talk about this c does not equal 0 thing, but let's just do a quick example. 3x equals 24. How would I solve that equation? Well, I would divide by 3. I would get x equals 8, and I would have arrived at that. How did I get from here to here? What looks different? Well, they divided off the 3. That's how I got x equals 8. So I divided the same thing on both sides, so that's the division property of equality. Now, the reason why it says c cannot equal 0 is because it doesn't matter what I have on each side of an equation. If I divide by 0, that's undefined. There is no such thing as dividing by 0. That's undefined. So c, or the value that you're, oops, I didn't write the right thing there, sorry. That needs to be a c right there. Divide the both sides by the same thing, not different things. I cannot divide by a 0. That is undefined. So that's the only reason that's in there. Okay, and then the rest of these are things that are familiar. Reflexive property is kind of a duh property, but it is going to be used later in geometry. I'll show you how in a little bit. But the reflexive property just says that this one thing is equal to itself. And you're probably going, why do we even need to state that? I'll tell you about that later, but the reflexive property in geometry is going to be related to making congruent triangles. And so we'll talk about that in a little while. The symmetric property is probably most familiar to you, or better known as the commutative property. That is basically that I can reverse the order and it does not change the value. Okay, so I can switch things to either side. I can make the A and the B switch sides. The transitive property simply says that if A is equal to B and B is equal to C, then that means that A and C must also be equal because they're both equal to the same thing, which is B. And I think about that, a transitive kind of sounds a little bit like transfer, so it's transferring from here to here. The substitution property you are very familiar with. You've done things like this before. And then it says if A equals 2 and B equals 6. Basically what you're told to do is take these values for A and B and substitute them into the equation, and then you would solve the equation. So this would be the same thing as 12. So that's all that the substitution property really says. If A equals B, then B can replace A in any expression. Any expression that I have, the two of them can replace each other, okay? Because they're equal to each other. And then the distributive property is one you're familiar with. That's where if there is something being multiplied with something inside parentheses, it's the same thing as multiplying it by each term and then adding them. And you're familiar with that. You've done that in algebra before. So those are your algebra properties. And in the next video, I'll do the geometry properties.